Assalamualaikum and hi everyone. Today I'm going to share about a traffic observation we did at the T intersection at Front Gate UiTM Shah Alam along Jalan Ilmu. Okay, let me introduce myself. My name is Muhammad Afif Shahmi bin Muhammad Yusof. My matrix number is 2023263056. The main purpose of this study is to look at the traffic issues happening there and understand what's causing them. Our goals is to suggest improvement that support SDG 11, which is about making cities safer and more sustainable. We focus on four main things: safety, how traffic flows, the road design, and how drivers behave in the area. This is five main points for the key traffic issues that we identify for our experiment. The first issue we noticed is that it's hard for car coming from the junction to enter the main road. This is because vehicles on the main roads are moving fast and there is no speed bump or warning to slow them down. So it is become quite risky to merge, especially when the traffic is heavy. Second, even though the road has two lanes, many drivers use side lane to move forwards without thinking the vehicles from another road to merge. This shows that the lane marking might not be clear enough and it creates danger for motorcyclists or another vehicles who might be using that space. Third, there is no clear signage or traffic light at the intersection. Because of that, driver don't really know who's supposed to go first. This causes delay and sometimes aggressive driving, which increase the risk of accidents. During peak hour, in the morning or afternoon, there are just too many cars using the road. The junction layout can't handle the volume well, so it causes long delays and traffic jams. And lastly, the design of the intersection is not practical. The turns are narrow and the central divider makes it harder for traffic to move smoothly. This leads to queues and congestion that even affect other parts of the road. Okay, we decide two suitable methods to determine for our experiment. For the first method we use is the spot speed study. This is to check how fast vehicles are going when they approach the intersection, especially on the main road where we observe most vehicles moving quite fast. We use either a speed gun or manual calculation where we calculate speed based on distance and the time. The data was collected during the time periods as the traffic counts, morning peaks and evening peaks, nighttime and weekends. From this study, we can see if vehicles are going too fast and whether there's a need for speed control measures like warning sign or speed bump to make merging safer. The second method we did a traffic volume count. The main purpose of this is to find out how many vehicles pass through the intersection at the different time of the day. We planned the observation over 3 days. We recorded traffic during morning, evening peak hour, as well as nighttime and weekend condition. We also separated the vehicles into categories like cars, motorcycle, bus, and so on. By doing this, we can clearly see when traffic is at its worst and whether the road layout can handle the volume. This helps justify the need for better traffic control, especially during peak times. That's all from me. I would like to give the turn to the next person.
Assalamualaikum and hi, my name is Nur Shakira Dini binti Muhammad Jabbar. My ID number is 2023-437 and 424. So today I'm going to present about analysis from the observation we have done at the junction that we're experimenting, and this is which we want to identify the problem at the junction. So this is the data that we obtained from the experiment of the observation, which is the traffic volume, and you can see the morning and evening is much higher than night and weekend. So problem that can be linked to the to the observation of traffic volume. As you can see, the morning is 1845 while evening is 1776. However, for night and weekend is respectively what 816 and 359 vehicle per hours. In the morning and evening from the observation, this intersection have cause of queue spillback. This area also have caused crash and collision. This happened because of the poor road alignment. Other factor can cause a crash is because the layout is confusing, especially for vehicle from V1 or V6 to make a turning. We can see the conflict happen during the turning. Delay do happen at this area, especially on the peak hours, because vehicle from the outside coming into the ITM also the one that going out from the ITM. So this is the picture that shown how confusing it is from here to there, from V6 to outside ITM, and from the outside into the UITM turning. So that's all.
Hello, my name is Nurul Amin Jananor Azmi with ID number 2022786375. So today I'll be present a brief speed analysis based on the 95th percentile spot speed along with some key issues identified. So firstly, let's look at the results. In the morning, the 95th percentile speed is 50.5 kilometers per hour. In the evening, it is 51 kilometers per hour. At night, the 95 percentile speed is 76.7 kilometers per hour, which is the highest value. And on weekends, the percentile speed is 25.5 kilometers per hour, which is the lowest. So let's look at the results and discussions. So at night, the 95th percentile speed is 76.7 kilometers per hour, which is the highest recorded. This is likely because traffic is very light at night, so drivers feel free to speed. However, this poses a danger since high speeds increases the risk of serious accidents, especially when visibility is low or enforcement is limited. So, during the morning and evening peak hours, the speed drops to around 50 kilometers per hour. This is moderate and makes sense given the heavy traffic during these times. While traffic naturally controls speed here, it can still cause problems such as sudden braking or aggressive driving as people rush to work or home. On weekends, the recorded speed drops dramatically to 25.5 kilometers per hour, which is the lowest. This likely indicates significant congestion, possibly due to local events, markets, or parked vehicles narrowing the roads. Such low speed clearly point to traffic flow problems. So, based on these observations, we can identify a few major issues. Firstly, we have speeding at night. Drivers taking advantage of low traffic to go too fast, increasing risk for all road users. Second, congestions on weekend. Extremely low speeds suggest overcrowded or poorly managed roads during off-peak times. And lastly, we have unbalanced traffic flow. The big difference between night and weekend speeds reveal inconsistent road performance, suggesting issue with planning and traffic control across different times and days. In conclusion, this analysis highlights the need for better speed management at night, improved planning for weekend traffic, and strategize to ensure more balanced and predictable traffic flow throughout the week.
Assalamualaikum. My name is Luqman Hakim bin Muhammad Mahdi and my number of student is 20232622 and 12. Today I will present the proposed mitigation for traffic volume based on the geometry layout, landscaping and speeding elements. Firstly, the direction signage. Queue spillback happens at junction V6 when drivers, especially outsiders, misunderstand the intersection direction despite road markings. This is due to the two-lane minor road merging with junction V3, causing confusion and traffic delay. Installing direction signage at point X can guide drivers clearly, reducing confusion and improve traffic flow by minimizing delays. This is the point X. Next, periodic maintenance. Intersection sight distance is the clear view drivers need to safely cross or enter traffic. During our investigation, a large trees at junction V2, V3 and V6 were found to block this view, causing hesitation and slower speeds. While these trees provide shade and aesthetic value, their branches should be trimmed monthly by UiTM's arborists to improve visibility. Better sight distance reduces traffic delays by allowing smoother and safer vehicle movement. Lastly, speed limit signage. Speed is the rate at which a vehicle moves. At junction V6, downhill roads cause drivers to speed up, creating danger and confusion, especially when many ignore turn signals mainly at junction V4. This leads to hesitation and traffic delays at V6. To reduce this, a 20 km/h speed limit sign can be installed at point X. This will encourage drivers to slow down, making it safer and easier for vehicles at V6 to cross, thus reducing traffic delays. And this is the point X.
Assalamualaikum. My name is Muhammad Haris Irfan bin Muhammad Razi, and I will be presenting the mitigation measures for the spot speed analysis. So for spot speed study, I will cover three elements, which is visual aid, where we will installing convex mirrors and also stop signage. Next element is the alignment, where we will installing speed humps and also rumble strips. And the last one is the cross section, where we will installing raised medians on major road and also minor road. So for the first element, which is the visual aid, we will install convex mirror and stop signage. We will install stop signage at strategic point to guide driver, especially at night. So the convex mirror will be improved visibility at blind spot, especially where buildings obstruct signline, especially on V4 direction, which is the major road. So will be installed on the minor road, facing the downhill approach to reveal upcoming traffic, and will be around 1.2 to 1.8 meter above ground to align with driver signline. So this is the example of convex mirror and stop signage, and will be installed at the minor road facing the downhill approach to reduce the speeding. So the second one is the alignment element. Will be installed speed hump and rumble strip. So the rumble strip will provide tactile warning to attentive driver, and we install the driver rumble strip on the V5 direction. Will create the wake up effect to alert motorists to reduce speed when approach the minor road. So for the speed hump, cushion can be strategically placed along the downhill segment of V4 direction to basically enforce speed direction. So the placement, we should consider the drainage needs, and also emergency vehicle access. So this is the example of the rumble strip and also the speed humps, and we will be installing at the major road to reduce the speeding before approach the minor road. So the last element, which is the cross section, we will the raised median for the major road. So the sudden and unseen U-turn are the common issue. So we will serve the raised median and effective physical barrier. We guide driver to a designated turning point while eliminating regular U-turn on major road and also on the minor road. So the median should be at least 0.3 to 0.5 high to discourage crossing, and the extend median at least 50 to 100 meter before and after the junction to prevent last minute swerving. So that's it for my presentation. Thank you very much.